Hello everyone, welcome to my channel. In this video we are going to see about the lithium batteries and how they are constructed and how the lithium battery is working. So coming up to the lithium battery, in previous video we have seen about the acid batteries. If needed you can refer that too. Then now coming up to the lithium battery. Lithium battery is also a rechargeable type of batteries where it converts chemical energy into electrical energy, vice versa. Then battery is made up of a anode, cathode, and separator, electrolytes, and two current carrying collectors, which means positive and negative collectors. So the anode and the cathode stores the lithium, and the electrolyte carries the positive charged ion, lithium ion, from anode to cathode and cathode to anode for charging and discharging. And this is how the lithium battery operates. Next is your components of a lithium battery. So the main component is your anode, cathode, then electrolyte and separator. So these are all uh, placed inside your batteries. So anode is a dedicated negative terminal uh, with an element of graphite or a carbon. Then cathode is your positive terminal with a metal oxide, lithium metal oxides. The metals can be a cobalt or a manganese, and titaniums can be used. Then electrolyte it will differs according to your manufacturers. So normally mostly it will be a lithium hexafluoride phosphate dipped in your ethylene carbonate solutions. These electrolytes are mainly responsible for your charging and discharging activities. Then separator is a kind of polymer which separates your positive and negative terminal inside your batteries. Next, coming up to the construction. So this is how the lithium battery inside will be. The anode, which is made up of graphite or carbon. Graphite in the sense naturally occurring carbons. So the anode is made up of a graphite or carbon. Then cathode is made up of a lithium cobalt oxide. In here, the metal oxide which we are using is cobalt. So this will differ. This metal oxide will differ according to the manufacturers. It may be a manganese or a titanium kind of thing can be used. So normally the electrolyte solution which is dipped inside your batteries, it is made up of a kind of a gel solutions. So the lithium hexafluorophosphate is used as a electrolytic solution, and the separator is placed between your two positive and negative electrodes, which means between your both electrodes. So this is how the total containment will be there. So outer box will be a plastics or a fiber kind of thing. Then the outer box which is a non-conductive. Then the positive and the negative terminal will be placed outside your outer box for connecting with the loads. Then the positive terminal is your lithium metal oxide, negative terminal is your graphite. During charging activities, the electrons will move from a negative to positive terminal. Then during discharging, automatically the lithium ions will move from a positive to negative terminal. So this is what happening during the charging and discharging activities. So next, battery measurement. Normally the energy density is measured in a watt hour per kilogram. So because the amount of energy the battery can store, that's the thing we are calculating the energy density. When coming to the power density, it is measured in a watt per kilogram, not watt hour. Because the power in the sense the amount of energy, which means the amount of power which can generate by the battery, or which can be given to the load section, that is your power density. So this is the battery measurement takes place. Next, mainly it is characterized by a two type of working. One is your charging activity and second one is your discharging activity. First, charging activities. When the battery is plugged into your electrical chargers, the lithium ion will move from a cathode to anode, which means your positive to negative. So in this way the charging carried out by an chemical reaction. Then if discharging in the sense, uh, vice versa, which means opposites to the movement. The movement of the lithium ion, the movement of the lithium ion will get reversed, which means it will move from a anode to cathode. Now negative to positive terminals this lithium ion will move. So from a negative electrode to a positive electrode, and the electrical energy get transferred to the attached loads. So this is how the discharging takes place. And some of the criteria are there for lithium batteries, because the charging can be made as a boost charging, float charging, and trickle chargings. Like boost in the sense charging, then float in the sense normal charging, and trickle charging in the sense slow and steady charging. So discharging in the sense we should not discharge fully. That's too upon the manufacturers. And maximum up to 30% of your total power can be discharged. This is the example of your charging and discharging activity. So during charging activities, the lithium ion get moved from a positive to negative terminal. And this is how the charging takes place. And during discharging it will get moved from a positive to a negative to a positive terminal, which means the lithium ion get moved from your negative to your negative anode to your positive cathode. So this is how the discharging takes place. Next, coming up to the advantage of your lithium batteries usage. Normally the lithium battery is having a very lighter weight and also easily rechargeable batteries. So uh, high specific gravity and high load capacities with power cells are being used for your lithium batteries. Then long cycle and maintenance free, because in acid batteries there may be a high chance of creating a certain gases during at the time of discharging and charging. So that can be avoided in your lithium batteries. Then high capacity, low internal resistance, good cubic efficiency of your batteries are being seen. Then they are having a high energy density, which means your watt hour per kilogram is very high, means the storage capacity is very high. Then there exists no memory effect in a lithium batteries. Low memory effect in the sense the battery charging, either it can be fully charged or even it can be used at a partial charging also, which means if the batteries are fully not charged also it will work. Then it does not produce any toxic gases, or during at the time of charging and discharging the emission of gases are not done in lithium batteries. Next is your disadvantage. So even though it is a good environmental, but there is some limitations in your lithium batteries. The charging capacity of your lithium battery get reduced over time, because it loses the lithium ions in the solid electrolyte interface and cathode electrolyte interface. So if the separator of the lithium ion get damaged, automatically the short circuiting get happened, and it will leads to a hazard, fire hazard. Then there are a relatively expensive in cost wise. Then the degradation at a high temperature, and when stored at a high voltage there may be a chance of a capacity low at your discharging lithium batteries. No rapid charge possible at freezing time, sorry, freezing temperature. So general disadvantage of your lithium batteries. Next, coming up to the maintenance of your battery. Normally the maintaining a battery in the sense at a ideally operating range, uh, the battery should not overheat or freezing. So normal temperature should be maintained at your battery room for charging and discharging activities. Then monitoring the current and the voltage to keep both at a safe level, because the the degradation takes place and forms a sulfonation in your anode and cathode because of this high voltage and current only maximum time. Then there is no memory built in pack. In the sense, the partial charging can be made in your lithium ion batteries and discharging during the time that most convenient for your equipment, because um, the in case of emergency, uh, the battery should operate or works in that time. It should not consider that the batteries are has to be fully charged or fully discharged, like that kind of thing should not be there during at the time of emergency. So these batteries are very much useful for that. It can be used even in a partial charging level also. Next, built-in controllers prevent overheating in order to prevent from a sulfonation that can cause significant damage to your lithium ion batteries. Then cell balancing is monitored so that the equalization charges are never needed, because they do not release dangerous gases. So these are all the things which need to be carried for your maintenance of the batteries. Next is your application. So this is a lithium batteries are very much useful in your real time uh, daily needs also. So in your mobiles, batteries are used as a lithium ion batteries only. Then for your medical equipment, due to its less weight and compactable, it is used in your medical equipment also. Then for the UPS and emergency power supply, there is for your inverters circuits, these lithium ion batteries are used. Then storage of your solar power can be easily made by the lithium ion batteries. Then alarm system in remote locations, for that also this lithium ion batteries are being used. Then for your electrical batteries, electrical vehicle batteries, this lithium ion batteries are being used. Then for your DSLR cameras, this lithium ion batteries are being used. So hope you have understand, I think so. See you in next video. Have a nice day. Nandri. Vanakkam.